Dear colleagues, I would like to present our study towards algorithmic and software solution for business process model analysis and correction, completed by me, Andrii, Kopp, and my colleagues, Olha Yanholenko, Dmytro Orlovskyi, and Uliya Litvinova. We both all represent National Technical University, Kharkiv Polytechnic Institute, Department of Software Engineering and Management Intelligent Technologies. So to begin, let's start with the agenda. Our study outlines introduction, related work, motivation and problem statement, formal business process model representation, correctness evaluation of business process models, business process model correction, results and discussion, and also conclusions and future work. Let's begin with the introduction. Quality assurance and correctness of BPMN models, business process model and notation, is extremely important to align business and IT aspects, detect inefficiencies in workflows, train employees, and guide process improvements. Using quality analysis techniques, it's possible to detect errors in BPMN models, improve workflow scenarios, and improve the overall organizational performance. A wide range of considered studies is devoted to the development of methods and tools for BPMN model quality evaluation, complexity assessment, correctness analysis and improvement, policy compliance analysis, and other quality aspects that may affect the efficiency of BPM practices. This study aims to contribute to BPM practices by proposing the tool for improving the correctness of business process models based on their structural analysis. BPMN is the most widely used business process modeling notation and has been widely adopted in industry and academia due to its powerful capabilities for graphical design and comprehensible description of complex workflows. Recent research has made significant contributions to the field of BPM and business process modeling, especially in the areas of business process model complexity assessment, correctness analysis and verification, quality evaluation based on modeling guidelines, and BPMN model redesign. Existing studies highlight the challenges of maintaining the correctness of BPMN models, as well as the importance of using design rules to achieve high-quality business process models. Therefore, this paper aims to contribute to BPM practices by addressing the challenges of business process modeling through the algorithmic and software solution for researchers and practitioners to analyze and correct BPMN diagrams. Formally, the structure of a business process given using BPMN notation can be described using the directed labeled graph. In this graph, we have the set of nodes that represent various business process elements like events, activities, gateways, and others, set of arcs that represent business process flow, and mapping that assigns textual labels to business process elements and flows. This set of textual labels is assigned to business process elements and flows. For example, some activity of the order receiving business process could be labeled as verify order to represent the task done by a manager, and some flow can be labeled as out of stock to represent one of the scenarios for this process. Therefore, we propose to check the build graphs from BPMN models and evaluate correctness based on these 6 process modeling rules we introduce. First rule says if the element is activity, such as task or sub-process, it should have one incoming and one outgoing flow. Second rule says if the element is an intermediate event, it should have one incoming and one outgoing flow. Third rule says if the element is a gateway, it should have either one incoming and 2 outgoing flows for split gateways, or 2 incoming and 1 outgoing flow for joint gateways. If the element is a start event, it shouldn't have incoming flows and should have one outgoing flow, the fourth rule says. Fifth rule says if the element is an end event, it should have one incoming flow and shouldn't have any outgoing flows. And the rule number 6 says if the element is a boundary event, it shouldn't have incoming flows and should have one outgoing flow. Then the main idea of the proposed algorithm is to sequentially verify invalid elements detected in a BPMN model using introduced rules and propose to fix these inefficiencies by adding missing flows. Using the proposed algorithm, the software tool is designed and developed to perform experiments. The proposed software solution is developed using the Python programming language and Python packages to process XML files, to perform computations using NumPy, to visualize results using Matplotlib library, and to save research results using CSV library. As the results, the total BPMN models attempted to process by our software tool was 3,729 from open GitHub repository by Camunda company. Our tool successfully processed 3,714 BPMN models, which is 99.60%. It also failed to process 15 BPMN models, which were of invalid syntax, which is 0.40%. The total time to process all the collection of BPMN models was 245.74 seconds. The average time for processing a BPMN model was 0.15 seconds. And the standard deviation of the processing time is 0.23 seconds, which in total these performance measures demonstrate quite good performance of the proposed algorithmic and software solution. As the example here, we demonstrate the original BPMN model that describes the goods dispatch business process of some small hardware store. And as can be seen from the left side to the right side of this slide, the missing flows were restored using the algorithm and software, and events, tasks, and gateways were modified to fulfill all the modeling rules. And now they are all properly connected and demonstrate the consistent workflow of this goods dispatch business process. Finally, in this study, to conclude, we have addressed the relevant problem of analyzing and correcting the quality of business process models in order to contribute to the BPM discipline and to face the major challenges in this area related to the design of understandable and maintainable business process models. The proposed approach is based on the graph-based process description, modeling anti-patterns detection like rules violations, and automated correction of these violations using corrections in the adjacency matrix of build process graph that represents BPMN model structure. As a test dataset, the collection of 3,729 BPMN models was used, in which the maximum processing time of a single BPMN model was 3.18 seconds, which indicates the reasonable performance of the proposed solution. In total, the used collection consists of 1,641 invalid BPMN models, which is 44%, of which 1,293 BPMN models, which is 78.79%, were improved in their correspondence to modeling rules, with 1,157 fully corrected BPMN models, which is more than 70% to comply with all introduced business process modeling rules from rule number 1 to rule number 6. Future work in this field includes the use of evolutionary optimization algorithms to increase the proportion of fixed business process models and software customization to be applied by end users. Thank you very much for your attention, and I'll be glad to answer your questions.